Hi everyone. Today I'll be looking at recurrence relation. This will entail the worksheet where I look at some questions where we need to, in this case, find the first 5 terms of the sequence given the recurrence relation. So what's different about this is that you are given the recurrence relation and we need to use that to create a sequence. So for example, the first one I have is an equal an minus 1 plus 3. We're given the first term, which is 5. So we need the second term, the third term, the fourth term, and the fifth term. So for A2, that means the second term, it is when n is equal to 2. So what do? We replace in the recurrence relation when n equal 2. This would be 2. And here I'd have a 2 take away 1 plus 3. So this would be a1 plus 3, but we already given the first term, which is 5. So that's why we would have 5 plus 3. So our answer for the second term is 8. Now, if I want the third term, which is a3, you can see that it's okay. It's going to be a3 take away 1 plus 3. So that's a2 plus 3. And we know that a2 we found to be 8. So that's 8 plus 3. And the answer is 11. So that means a3 is equal to 11. The next one we have is a4. So a4, I will have a4 take away 1 plus 3. So that is a3 plus 3. And we know a3 is 11, so I'd have 11 plus 3, and that will give me 14. Then for a5, if you are looking at the trend, a5 would be a4 plus 3, which is 14 plus 3, and that will give me 17. So the first 5 terms of the sequence is 8, 11, 14, and 17. So those are the first 5 terms. Let's look at another one. We have the second one, and then I'm going to look at the third. The fourth, I'll allow you to try on your own. For the second one, we have an equal 5 an minus 1, where a1 is equal to 3. So we have the first term. So what we're going to calculate, what is the second term? So the second term is when n equal 2. So I replace n to be 2 in the recurrence relation. And 2 minus 1 is 1. So that means I'll have a2 equal 5a1. And a1 in the question is given as 3. So this is 5 times 3 to give me 15. Then we have a3 when n equals 3. So this is 5a, 3 take away 1. So that's 5a2 is equal to 5 times a2 is 15. So now, in this case, we are multiplying by 5. So 5 times 50 will give us 75. Then a4, if you look at the trend, a3 was 5a2. So I'm hoping you're saying a4 would be 5a3. So that means it's 5 times 75. So my answer would be 375. Then we have A5. It would be 5 times A4. So it'd be 5 times A4, which is 375. So 375 times 5, that's 1,875. So the first 5 terms is 15, 75, 375, and 1,875. So that represents the first 5 terms of the sequence. Now, if you look at part 3, that's the last one I'm going to do in this question. And then the next one, you will have to go ahead and do it on your own. Now, we have the recurrence relation is an equal an minus 1 plus an minus 2, a1 equal 1, a2 equal 2. So in this case, you're given the first and the second term. So we're going to start off with the third. So the third term is when n equals 3, so replace 3 here. So we have a3 take away 1 plus a3 take away 2. So this is a2 plus a1, and the question gave us a2 to be 2 and a1 to be 1, so that means a3 is 3. A4, if you're not seeing how this is going to be 3, a3 plus a2, we can see it's a4 take away 1 plus a4 take away 2. So that means it is a3 plus a2. a3 is 3, a2 is 2, so that means this is 5. So it means that a5 would be, looking at the trend, it would be a4 plus a3. So a4 is 5 and a3 is 3, so my answer is 8. So therefore, I will have 1, 2, 3, 5, 8. And that's the sequence. Now, for the next one, we're moving in the reverse. We're finding the recurrence relation. So before, what we did, we got the recurrence relation and we found the sequence. So now we have the sequence and we're trying to find what is the recurrence relation. So the first one, we have 3, 7, 11, 15. We have to look at what's the pattern here. And if you look at this, I have to add 4 to each term to get the next. So what that means is that we have a1 to be 3. And to find a2, I have to do a1 plus 4. To find a3, I have to do a2 plus 4. And to find a4, I will have to find a3 plus 4. So basically, what's happening here is that I have to add 4 to each term to get the next. So now we need to find out what's the recurrence relation. We start off by writing it as an. Now we can take one of them and say, okay, if n is equal to 4, what do I have to do to get this number to be 3? If this is 4 and I put n to be 4 and I want this to have the subscript 3, then it means I have to do and take away 1. That's the only way I'll get 3. 4 is a constant, so I'd put a plus 4. And given that for A1, I had to use it, so A1 equals 3 is a part of the recurrence relation. So that means we'd substitute for n values greater than or equal to 2, because we start at n equal 2 to find the recurrence relation. For the next one, we have 3, 6, 9, 15, 24, and we have 39. Once again, we have to look at the pattern. And in this case, A1, we have it as 3. But if you look at to find the second term, if I say I have to add 3 plus 6, if I have to multiply 3 times 2, it doesn't work for the next, because if I multiply 6 times 2, it doesn't work. However, if we add the first two terms, 3 plus 6, that gives you 9. If I add 9 plus 6, that gives me 15. If I add 9 plus 15, that gives me 24. So we have to start off with A1 and A2 to get the result. So to get the third one, I have to add the first term plus the second term, which is 3 plus 6, and that gives us the 9. To get 15, which is A4, this is 15, which is A4, I have to add 9 plus 6. That gives you 15. So we had to add the second term plus the third term. And if we go again and look at A5, which is the 24, we have to add the fourth term plus the third term. So this is the sequence, the trend. And what we have to do now is determine what's the recurrence relation. Well, let me rewrite it so that it goes in the order that's here. So the third term plus the fourth term. But the order doesn't matter. So the recurrence relation, we start at n. So we have an. This is saying when n equals 5, what do I have to do to get this to be 3? I have to subtract 2. So that's going to be n take away 2. What do I have to do to get this to be 4? I have to subtract 1. So this is an take away 1. Now, we did not use a recurrence relation to get A1 and A2. So we have to write that we need A1 to be 3, and we also need A2 to be 6 in order to start this sequence. So we need these two in order to work out A3, A4, A5, and continue. And it means that we're starting when n is equal to 3. So we're going to work out for when n is 3 or greater. So this represents the recurrence relation. For this, if you realize, we have A1 to be 1, A2 to be 1, and then this is A3 to be 2, A4 to be 4. So looking at this, we have to look at how do we get the third term. So we have A1 is 1. A2 is 1. For A3, we have 2. How can we get 2? It would be the first term multiplied by the second term, and then we times it by 2 so that we get 2. So the first term times the second term and times it by 2. following that same trend. So whatever you are doing, it has to be the same pattern in order to get all the numbers. So for A4, which is 4, remember I multiply by 2 on the outside. I will have to say, okay, if I use the first and the second, then this one, I would use the second on the third. So it'd be A2 times A3. Given that A2 is 1 and A3 is 2. So 1 times 2 is 2. Then you times it by these 2. So 1 times 2 is 2, and times it by 2, you get 4. If we look at the next one, which is A5. A5, we have it to be 16. So looking at the trend, it's going to be 2 times A3 times A4. Does it work? A3 is 4 and A4 is 16. A3 is 2 and A4 is 4. So 2 4s is 8, and you times it by 2, you get 16. And the trend continues. If I multiply 4 times 16, then times it by 2, I get 128. 16 times 128 times it by 2, I get 4,096. So that's telling me that A5 is equal to 2 times A3 times A4. So it's just for us to know, right, the recurrence relation. So if I put n to be equal to 5, because recurrence relation always starts at an, I'd have this 2 because that's constant. Then I think about what should I subtract from 5 so that I get 3. It will be 2. So that means this is an take away 2. What do I subtract from 5 to get 4? It will be 1. So this is A5 take away 1. So that's an take away 1. Now, in order to do this, we need A1 to be 1, and we need A2 to be 1. So what that means, we're starting at 3. So n should be greater than or equal to 3. Finally, here we have 4, 12, 36, 108, and 324. So we need the first 5 terms of this sequence. So we need the recurrence relation. So this is telling us that A1 we have 4. If you look at each, let's take our calculator. You multiply 4 times 3, we know that's 12. We know that 12 times 3, that's going to be 36. Now, if you put in your calculator, if you're not sure, 36 times 3, you will see that you get 108. And 108 times 3, you will get 324. So what's happening here is to get the second term, I have to multiply the first term times 3. And to get the third term, I have to do a similar concept, which is to 3 times the second term. And to get the fourth term, I'm hoping you're seeing it's 3 times the previous one, which is A3. So the recurrence relation is that an is equal to 3a. Now remember I said, if this is 4 and I need this to be 3, you have to take away 1, so it'll be n minus 1. But given that we need the first term, which is a1 equal 4, to find the recurrence relation, then it means that for this situation, we are going to start at n equal 2 and continue upwards. So that represents the recurrence relation. To solve the following recurrence relation, so let's look at the first one. So we have x to the n equal 6n minus 1 minus 5 x to the n take away 2. Where we have x0 equal 1 and we have x1 equal 5. So first thing first, we're going to carry these over the equal sign. So we have this to be x to the n minus 6 x to the n minus 1 plus 5 x to the n minus 2 equal 0. Now something to note, this is going to become a quadratic. It's called the characteristic equation. And just a little, background. If I have x to the n, we can rewrite it as r to the n. Then we have now we need to write the characteristic equation, and the characteristic equation, this will become r squared minus 6r plus 5 equals 0. And solving, what we're going to do is factorize. So you can say two numbers that multiply to give me 5, and when I add, I will get -6. My answer would be, I'm hoping you're saying -1 and -5. Now the shorthand way is just to write r minus 1 and r minus 5, but if you prefer to go ahead and factorize completely, then I'd have minus 1r here minus 5r plus 5 equals 0. So you put these in brackets, and what can we factor out? We factor out r, so we left with r take away 1, and here I take out -5, so I'm left with r take away 1. So that means I have r minus 5, and I have r take away 1 equals 0. So that means r is equal to 5, and r is equal to 1. Now, what is the general solution? We can write the general solution as x to the n, because it's x we're dealing with, is equal to a 5 to the n plus b 1 to the n. Now we were given initial conditions, so we're going to use those to find out what is common A and what is common B. So what we're going to do is substitute. You have x0 equal 1. So that means when n equals 0, we'll have a 5 to the 0 plus b 1 to the 0. So x is 0. I could go ahead and say x0 is 1. So I'd have 1 here. Anything raised to the power 0 is 1. So that's a plus b. The next one we have x1 equal 5. So that means we have x1 substituting into the general solution. So x1 equal 5a, So x1 equal a 5 to the n, and n is 1, plus b 1 to the 1. x1 is 5, so I'd have 5 equal, this would be 5a plus b. So we have two equations. We have a plus b equal 1, And then we have 5a plus b equal 5. So solving it simultaneous, because these are the same, I am going to subtract. So a minus 5a, that's going to be negative 4a. B minus b is 0. And 1 minus 5 is negative 4. So divide both sides by minus 4. So that means a is equal to 1. Now we have a plus b equal 1. So since a is 1, I'm going to put a 1 here. So 1 plus b is equal to 1. Carry over this, so we have b is equal to 1 minus 1, so b is 0. Taking the general solution, x to the n is equal to a5 to the n plus b 1 to the n. What's a and what is b? If you realize, a we found to be 1 and b to be 0. So by right, this would be gone. So we just have 1 times 5 to the n is 5 to the n. So the particular solution is xn equal 5 to the n. Let's look at the next one, where we have bn equal 2bn minus 1 minus bn minus 2. Where we have b naught equal 5 and b1 equal 8. Now, we don't need these as it. So the first thing first, to carry these over the equal sign. So we have bn minus 2, bn minus 1 plus bn minus 2 equals 0. So this is going to be the characteristic equation. So we're going to have r squared minus 2r plus 1 equals 0. So now we need to factorize. Two numbers that multiply to give me 1, but when I add, I will get negative 2. It's only going to be negative 1 and negative 1. So that means I'll have r squared minus 1r minus 1r plus 1 equals 0. Then I group. What can I factor out? I can factor out r, so I'm left with r take away 1. What can I factor out? Negative 1, so I'm left with r take away 1 equals 0. So that means I have r take away 1 and I have r take away 1. So that means solving r is equal to just 1. So when we have repeating roots for the general solution, we would have bn is equal to, this would be a 1 to the n plus, then I would have bn 1 to the n when you have repeating roots. Now we got b0 to b5. So we're going to use these to find out what is a and b. Now, that means when n equals 0, so I'd have b0 equal a 1 to the 0 plus b, this would be 0, and this would be 1 to the 0. So by right, this is gone. b0 is 5, so I'd have 5. 1 to the 0 is 1, so it's just that a equal 5. So now we can do the next, where we have b1 equal 8. For b1 equal 8, I replace n to be 1, so I'd have b1 equal a 1 to the 1 plus b You'd have put 1 here and 1 here. So by right, let me just adjust my screen so that everything can show. So to have B 1 and then 1 to the 1. So by right, B1 is 8. A is 5, so this would be 5 times 1 is 5. And then this would be plus B, because 1 doesn't affect anything. So carrying over the 5, we have 8 minus 5 equal B. So that means B is equal to 3. So now we can go ahead and write this as Bn equal 5, 1 to the n, plus 3n, 1 to the n. And that's the particular solution. And that's it.